You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. To answer this question, we need to start with the correct coordinates of negative 2 pi over 3, and then we are going to use that in order for us to solve the 6 trigonometric functions. Let us illustrate the coordinate using this unit circle here. This is also known as a unit circle because the distance of any point on the circle to the center is just equal to 1. We need to start with identifying the location of negative 2 pi over 3. Of course, we already know the coordinate of pi over 3. We can memorize that one or familiarize with that. We all know that the value for the degrees, in terms of degrees for pi over 3 is 60 degrees. And the coordinate of pi over 3 is the combination of x and y values with, we can see that here, by the way. This is where we're going to see pi over 3 somewhere here. Okay, so this is, we're going to have our point. That's actually, you would see that one is 1/2 of x, so you will know that x is 1/2, and our y is closer to 1, which is square root of 3 over 2. This is not the value or the coordinate for negative 2 pi over 3, but we are just going to copy this figure. So that would mean the coordinate of negative 2 pi over 3 will have the same combination, but we will be changing the signs when necessary, as long as we were able to identify the location of this, of the terminal point of this arc. So it's just the same, we'll be just changing the sign. Now negative 2 pi, since it's negative, we're going to move clockwise, and we know that this is pi here, so this is negative pi. This would mean this negative pi would be divided to 3, hence over 3. So we can have this portion here and here. So we have 1 or negative 1 pi thirds. We have negative 2 pi thirds, which is here. The location of the terminal point of negative 2 pi thirds is at the third quadrant, or quadrant number 3. What does this tell us? We will just be changing the sign of our x and y, since on quadrant 3, x and y are both negative. So instead of positive 1/2, it's just minus or negative 1/2. Instead of square root of 3 over 2, we have negative square root of 3 over 2. This is the point of our or a terminal point of negative 2 pi over 3. And we'll be using this to solve for the 6 trigonometric functions. Let's start with the cosine. Cosine of negative 2 pi over 3. The cosine of negative 2 pi over 3 is actually the x value of our coordinate. Okay? In short, the cosine of negative 2 pi thirds is negative 1/2. See? That's very important for us to have the correct points, or the correct combination of x and y for our point, in order for us to solve for our cosine. The second easiest is actually the sine, which is the partner of cosine And this is actually the value of the y here. So our the sign of negative 2 pi over 3 is negative square root of 3 over 2. Okay? Now after that, we can now solve for tangent. That because we already have our sine and cosine. Since our tangent of negative 2 pi over 3, okay, is the ratio of sine of the same angle, same arc, negative 2 pi over 3 over our cosine. Okay, sorry. We have cosine negative 2 pi over 3. So we simply take their ratio in order for us to solve for the tangent. So we have the sine, which is negative square root of 3 over 2 over our cosine is negative 1/2. We are multiplying, or rather, we are dividing two fractions. So we're going to use here the keep, change, flip method. We're going to keep our numerator, negative square root of 3 over 2. Instead of division, change it to the multiplication and reciprocate our denominator. So we'll flip that, keep, change, flip, 2 over negative 1. With this, we can cancel 2, we can cancel negative. That would mean tangent 2 pi over 3 is the ratio of square root of 3 over 1, or simply square root of 3. We are not done with the first 3 of the 6 trigonometric functions after we have understood the terminal point of our arc. Now let's proceed to the next 3. Now this next 3, you don't need to really memorize their structure, but you can simply look at the idea that all of these next 3 are reciprocals of the corresponding items here. So let's have the cotangent of negative 2 pi over 3. This is actually the reciprocal of your tangent. Okay? Reciprocal of our tangent, negative 2 pi over 3. We already have our tangent here. That would mean would be 1 over square root of 3. This is our cotangent, negative 2 pi over 3. But of course, we usually rationalize expressions if we have radical expressions on our denominator by doing the correct process of multiplying a certain value equal to 1, but by multiplying, the radical expression or the radical sign of our denominator will be removed. We are going to multiply this. You might want to review this process. Square root of 3 here, because square root of 3 times square root of 3 is square root of 9, will give you a result of 3. Okay? But for the numerator, for this entire expression be equal to 1, it should be square root of 3 here as well. Don't forget that. This is just equal to 1, right? That's just equal to 1. So you're not necessarily changing the value of cotangent negative 2 pi over 3, but you're just changing the form of the expression. So 1 times square root of 3, you have square root of 3, and this is your cotangent of the said arc. Let's proceed to second. Second is related to our cosine. Second is the reciprocal. So you have of our cosine. So you have cosine negative 2 pi over 3. We already have our cosine earlier. So this is 1 over negative 1/2. So we have an integer here to be divided with a fraction. But this integer could also be written as 1 over 1, right? Because 1 over 1 is just 1. So keep change flip method just like this. So we're going to keep our numerator. We change the operation to multiplication, and we flip our divisor. So you have 1 times 2 is 2. 1 times negative 1 is negative 1. 2 divided by negative 1 is negative 2. This is our second of negative 2 pi over 3. To finish this, let's have the last. We have the cosecant of negative 2 pi over 3. This is now the reciprocal of our sine. Okay? That is why it's very important for us to determine the first 3, sine, cosine, and tangent. Once we have this, we just simply reciprocate. Let's put it here for a better space. This is 1 over our second sign rather is negative square root of 3 over 2. Same as earlier, this 1 can be 1 over 1. So we're going to have here the keep, change, flip method. We keep the numerator 1 over 1. Change the operation into multiplication. We flip our divisor 2 over negative square root of 3, which gives us, okay, I'm gonna place the negative here, negative 2 over square root of 3. Same as our cotangent, we will rationalize this with square root of 3 over square root of 3. Okay, that's rationalizing denominators. Hence, you will have the final result here of negative 2 square root of 3. You simply multiply numerators over square root of 3 times square root of 3, which is square root of 9. That's just equal to 3. So these are the 6 trigonometric functions of the arc negative 2 pi over 3. Again, we started with remembering the correct coordinates of pi thirds, just like this. And then we locate the quadrant of our angle here. We change the sign for the correct points. And then we solve for cosine, sine, tangent before the last 3. Thank you for watching.